Um, Thank you so much, guys, for joining. Before diving into the DePIN panels that we're going to have today, we have this first privacy AI panels with some of the main players here. I want to give them, maybe you guys could do like a very short intro first, talk about your project, give us a quick intro, and then we can dive into a few questions, okay? Okay, we can start over there.
Hey everyone, nice to meet you. I'm Juan Angel, Ecosystem Growth Lead at Nillion. At Nillion, we are powering the blind computer, which essentially means that you can tap into privacy for any application you're building on-chain or off-chain, and I'm sure we'll go into more detail today as to how we're accomplishing that.
Hi everyone, I'm Yannick, co-founder and CEO at Arcium, and at Arcium we're building the encrypted supercomputer allowing for any kind of computation to be executed in a fully encrypted way.
Hey guys, I'm Rafi. I'm an applications product manager at Aztec, and we are building the universal zero knowledge language, Noir, and we're about to launch our private L2 here in a couple of months.
Hey guys, I'm Pierre. I work with Nillion. So yeah, we are working towards user-owned AI. So basically, it's the idea that we don't rely on centralized parties anymore, and everybody can own their data and their AI, and you can actually verify everything. You don't have to trust these centralized parties.
Cool. Hello, my name is Madao. I'm founder of Unipay. So we're building a yield-bearing stablecoin protocol. So currently we're leveraging based on Transformer to create a on-chain trading AI. So with different models, so we'd love to, happy to be here. Yeah.
Thank you. So yeah, we're going to start with the typical question. And I want to ask it to all of you, and how do you tackle that? Why is Web3 important for AI? And can we give you guys a particular view on this? Who want to start?
So I think Web3 and AI sort of have emerged over the last few years, and originally it really started as this sort of forced marriage, feeling quite artificial. Why should Web3 and AI now intersect? And that came really with the advent of new, more powerful models. I think Web3 and AI play great together because AI in its current form is heavily centralized, heavily relies on centralized players, and by being able to decentralize AI, by being able to add privacy, add data protection, add training workflows where the data belonging to every single human being can be used to train more powerful AI models without having to send this data to some centralized player, which then can reap in the economic benefits of creating those models. Instead, we can go as far by using decentralization and cryptography to build end-to-end encrypted AI, where we can have encrypted data that is being used to train models, have the models that are being produced remain in a fully encrypted state, and then people can run inference into those models, again, with sensitive encrypted data, not seeing the model, not seeing the data that has been used to train those models, not having to expose their own data. So being able to end-to-end encrypt AI, that's what's being enabled by adding decentralization. And decentralization is only possible at that scale with Web3, with distributed ledgers. So I think that's the big power, being able to add privacy. And privacy at the end of the day just means bringing data ownership to whoever has data. Yeah.
Thank you, Yannick. And can you guys tell us, in your different project, how do you guys tackle this intersection? Like, what do you bring to this intersection with the specificity of your particular project? Iris, do you want to start?
I can first answer that first question as to where Web3 and AI intersect and what's interesting about it. I think you hit a lot of key points, but I would add that Outlier Ventures had shared this post-web thesis about what the internet will become, especially post-AI. And I think I would break it out into consensus and then also cryptography. And I think what I'm the most excited about is verification, because I think right now there are trust assumptions when we use our phone and look at social media, look at information on the internet, where we assume that things are real until proven fake. And I think that this assumption will flip, where we'll now see things that are totally plausible, videos of close family members speaking that seem entirely real, but without any kind of verification, we won't be able to believe it. So I'm especially interested in this cryptography piece, and where we're trying to solve it is by building private smart contracts, where we think a lot of the way in which we want to verify trust assumptions around these models, around input, around output, those things need to be out there in the open, and that's where I think like Web3, cryptography, and consensus tie-in is private smart contracts.
Yep.
Yeah, I mean, one thing I think is very interesting about the merger between crypto and AI is most people who have been in crypto for a while are very familiar with the terminology or the phrase, not your keys, not your coins, but not your keys, not your data is another phrase people should get familiar with. And, whether you're aware of it or not, you're producing valuable data every single day. That data fetches a price on the open market. There are data aggregators, there are data brokers, they're buying and selling it. So, whenever somebody tells you your data is worthless, then you should probably ask yourself, why is it that a pharmaceutical research company would pay 23andMe $20 million to access their genomic sequencing data sets? And that ties back to what we're trying to build at Nillion, which is really give every user a very seamless and intuitive, user-friendly experience where they can own the encryption and decryption keys to their data, and then port that data over into any application that they're able to leverage to their own benefit. And that's where we're kind of flipping around the model, where instead of you providing data to somebody else to train their models, which may eventually and probably be used against you to some degree, and it depends on what their intentions are, or whether it's just for profits or something more malicious. That data is being put out there, and once it's out there, it's irrecoverable, right? It's always going to be out there, and you're never going to get it back. And so with something as sensitive as, for example, healthcare data, medical research in particular, these are data sets that fetch a high value. And so if you can not only ensure that you are the only one with the keys to access that data and then run any sort of computation you want on it, you have access to the things that previously in the past only the wealthiest of the wealthiest were able to tap into. So and you're able to do that without compromising yourself and putting yourself into a position where then that data might end up in hands that you don't want it to end up in, and that's not only going to cost you more, like for example from an insurance policy perspective, but where that data could actually be used in more nefarious ways. So the long and short of it is that at Nillion, we're decentralizing all of this compute so that no single node in the network is able to have full access to all of the information you're providing. And therefore, when you are running these models on this very confidential, very sensitive and proprietary data, and it could be anything, not just healthcare, it could be company secrets, corporate espionage is a problem that everyone's aware of and everybody has to be careful with. You're sure that there is no one single party that you have to trust with this data, and therefore you're able to get insights that are very, very relevant and useful to you. But you can go a step further and say, okay, now that I've learned something about myself from this genomic sequencing I did with, for example, an application building on Nillion called Monadic DNA, you can say I actually want to use these data sets and this information I've surfaced to sell to medical research companies on a per-use basis without them ever actually seeing the underlying data, but rather just being able to retrieve outputs based on the inputs I've provided in a way that's not traceable or tracked back to me. And that's really a very simple data flow. I like to say with Nillion, you're sad. Without Nillion, you're sad because you're not making any money from your data. And with Nillion, you're happy because you are. And that's a very simple way to remember it.
Wow, thank you guys. And I think maybe we can take from Nir's side. So how Nir, what the particularity now with Nir, and how do you power the infra for decentralized at the moment?
Yeah, so for the AI side of things that we are doing, we are leveraging a protocol that we have for, Nir is very fast, very cheap, and very, 100% uptime for a few years now. And so we are really using this to do like a lot of microtransactions between agents, then because you can use this open ledger to actually verify all the interactions between these agents, which is like super important because right now all these centralized parties it's like super black box. You have no clue what's happening. And you just rely on them, hopefully, that they're going to run your agent, and they're going to do the interactions that they're supposed to do. But here, actually, you can audit the full stack, and you can see what's happening between these different agents. So yeah, payments is one thing. Interactions between these agents is another thing. And on top of this, we are adding like TEs, so it's the buzzword. Basically, we are running these agents in a trusted execution environment. This allows us to basically prove to the users and anyone that what's running inside this TE is actually what you expect it to be running. And so it goes following the idea that you can verify everything. You don't have to trust any more single party. You can actually build the code yourself, read all this, and read all the code, and actually you are sure that your agent is actually behaving the way that it's supposed to behave. But yeah, so we are using Nillion protocol for basically every interactions between these agents, because without this, you have no way to actually check what's happening behind these very complex agents.
Thank you. And from Unipay perspective, guys, you guys have some payment between the different agents and etc. Do you want to give us your view on that?
So there's two major thing in this industry. So when we're training AI, or like for example in GitHub, the most trending repo right now is EXO. It allows you using different device can train the DeepSeek or Llama 3. But the problem is when you're using different device, you can make it as a decentralized service, decentralized protocol. But the data on chain, you cannot make sure it won't be exposure, the sensitive data especially. So how we integrate like the new area like ZKML doing, how to like when we're doing inference, how we protect this data on chain based on like maybe create a ZK snark on it, or maybe create a like TE or like FHE based on it. Like there's a few companies actually trying to do that, but the scale is quite small right now. So my idea right now is about like when we're trying to build a new kind of system, how we fix the problem about when we're using FHE, the computation power problem, the speed especially, there's my major problem when I'm create a decentralized trading system. Yeah, I'd love to know about like, especially when you guys how do it.
Yeah, so what we're doing at Arcium, what we've been doing over the last few years, building on Solana, I guess, is adding privacy there, and we ourselves have gone through an evolution, I guess, originally starting with zero-knowledge proofs and trusted execution environments, and then expanding to building our own secure multi-party computation protocol, fine-tuned for running encrypted on-chain operations. So that protocol that we've been developing over the last few years comes with the lowest possible trust assumptions and censorship resistance guarantees that you have for any general purpose MPC protocol. But for running machine learning, for doing AI, what you need is an incredibly powerful backend where you need to be able to run real number arithmetic and tensor operations, right? And that's why within FHE and CKML, that has been extremely expensive. Luckily for Arcium, I guess last year we had the chance to acquire our largest Web2 competitor, who've been doing exactly that, training private AI over sensitive data for defense, healthcare, and TradFi. And they've been developing their MPC protocol for more than 8 years, and we are making that available within Arcium as well. And then you can not only train models, but as I outlined earlier, you can go as far as building end-to-end encrypted systems, where you can say, okay, here's data that is being aggregated by using DePIN or some party providing data. Every human, for example, if we think about healthcare, right, or let it be hospitals. And the models that are being produced, they remain encrypted. And then someone can just deploy these frameworks in a smart contract where you say, okay, now there's an incentivization mechanism that you can pay for an inference into that encrypted model, or you pay for access to that model or pay for access to the data, whatever. It can be structured however you like it, but at the end of the day, it gives ownership to whoever provides this original data. And then you can have this autonomous execution over the encrypted state, the encrypted AI models, without having to expose anything. And that is,
So how do you handle, like, with private, like, verifiably private AI compute How are you able to do that with an encrypted model, like with an encrypted LLM? You're able to like.
I mean, so this specific protocol, the Manticore protocol, that is, we can run LLMs in them. However, that makes it less efficient than doing mainly machine learning and neural networks inside of it. So for LLMs, I would say it's still impractical to use these 100% purely cryptographic solutions. I mean, it depends on the number of tokens and the size of the models. We've run LLMs within MPC in a fully encrypted way. It's entirely possible, but I think for being able to actually make that something to be desirable, we need to optimize more. So that may take a few more years. Machine learning, neural networks, all these kinds of AI applications, which actually are some of the most important AI applications, I think. You can run entirely in an encrypted and verifiable way without the performance degradations you see in FHE and ZKML now.
So you guys mentioned a bunch of different tech, right? There is a lot of things involved now. There is some data, there is some models, there is some different type of encryption, different type of environment. What are the biggest challenges that you currently think for people? Because, okay, so we have this infras now, we have the capacity to eventually run a privacy AI and etc. But what are the current challenges? Why are we not seeing more application yet? What is currently making things slower?
I think that, to me, maybe to go back to this first question a little bit, I see all of these technologies working together. MPC, using blockchains, using FHE, using ZKPs, all of these together is what will ultimately be like the real world solution, where right now like the trade-offs are enormous. We're giving up all of our privacy for all of these AIs, especially for OpenAI or Claude and Anthropic. So I think like the pragmatic solution is what I'm especially interested in. And as far as like constraints, there are many. I remember a talk at ETH Bogota that Arcium did about proving a neural net for image recognition, and the actual inference was like under a second, but the proving was like a minute or something, right? So like a lot of these things are just not in a place where they're effective yet, but I think that there are ways that we can be creative with it, and then there's ways that we can like fine tune. So for inference, everything with ZKPs, everything needs to be represented as a circuit constraint. So there's complexity there. But if you're AI maxi, as I am, maybe even an AI doomer, but if you're AI maxi, then you could believe that maybe AIs can train to improve how these circuits are written, so that constraints can be optimized. I also think there's ways that you can selectively pick what you prove, so you don't have to prove an entire LLM. You could also have LLMs that are built specifically for privacy, where you have like a very small model meant for very important decision making or different use cases. And then you can also use these other technologies, as I mentioned. So MPC, there's a great company called Taseo. They were founded by Andreessen recently, and we're actually working with them to enable MPC on Aztec's network, where I think the combination of MPC with private smart contracts and our hybrid state, where we also have public state, can make for many interesting use cases around like healthcare or around like financial applications. So again, I think like the combination of all of these things and taking advantage especially of like the programmability of certain platforms like Aztec, like Alio as well, can make for real solutions that give up some compromises, because I think like right now we have to accept that the majority of people who are using AI are giving up all of their data. The majority of us, including in Aztec, I often bring up how we're using Google Docs for most of our writing, Slack for most of our messaging, and there are many trust assumptions that we're making with the tools we're already using. So I think the pragmatic approach is what I think will end up winning.
We discussed a lot about the drawbacks of fully private weights. If you want to run your model in an MPC or something like this, how it's super slow and you have like huge performance overhead and it gets like very, very slow. And I think that's where like TEs comes very handy. So we managed to run like very large models. So I'm speaking about LLMs here. But for example, we run DeepSeek V3 in a TE and it works perfectly fine. It's a huge model, and then you have the overhead was like we did non-TE versus TE. It was like 1%, which is.
Can I say one point on that?
Yeah.
I would say with T's versus it's like trusting hardware versus math. So there's different trust assumptions for sure. I think like again for one example for us that's really interesting with T's is like dark pools. So dark pools is a great place where we need the speed for trading. So there are people who are building dark pools on Aztec, and you really, the only way that that could be feasibly done as far as order books and execution and speed is with T's. I think there are many cases for like, let's say like financial auditing. Let's say you have like an AI like for detecting fraud for a bunch of banks. And so let's say all these banks want to like collaborate on this. I think there's use cases where T's will make sense. Where everyone agrees that we're using the same like hardware, but then you still would want ZKPs, let's say, to verify that like certain compliance rules were met, or that like models are not poisoned, or so I think again that like the pragmatic approach is a combination of a lot of these, and T's will enable a lot of really powerful use cases. I think like they solve for a lot of these constraints around like especially like the time it takes, but yeah.
Yeah, so for TEs, as long as it's not, if we speak about Intel TDX, which is one of the, like it's a solution from Intel that allows you to run these TEs, as long as TDX is not hacked, like you can actually do all the same stuff. You can get the measurements out of the actual workload inside these TEs, and then like, it's actually you get the initial state and everything around the TE, and then you can prove that actually what's running is what you expect it to run. So if you speak about poison model, for example, this you would know from, because it's in the state when it starts, you can actually check what's being like run, and as long as the model is correct, it's going to be correct inside the T. As long as the T is not unsafe.
Yeah. Little things. Talk back to the poison model. So the major part is how we can do the attestation on chain. So like there's a company which is our sister company called Primos. Also doing some like ZK TLS and on-chain attestation. Like for example, in Linear, they doing some thing called proof of humanity. They can like prove off-chain KYC data, or if you have a real Binance account or some real fact data on-chain. Like when you're trading your model, the major problem is you don't know is that the real data or something. So we need a legit attestation service to help us get the data source. Yeah.
So it seems like the underlying theme is that you have to be pragmatic, or else you get stuck in the theoretical. And that's the approach we've taken at Nillion, where what we're offering out of the box is the PetNet. The PetNet, where it's basically privacy-enhancing technologies, but a combination of them, right? So one of the biggest hurdles for developers wanting to leverage privacy technologies is that they'd have to become experts in everything we've been discussing today, when they have to have their own areas of expertise, right? And obviously that's unfeasible, and we can't expect everybody to do that. So by abstracting away a lot of these technicalities and the complex logic behind what kind of privacy do I use for what kind of data sensitivity, we're offering this out-of-the-box plug-and-play SDK, where all of a sudden you can tap into all of the benefits of having private data that is also, sounds like it's a contradiction, but it's, by it being private, it becomes open, because then you can plug it into all these other types of applications and programs that allow you to leverage data that you've generated in one private app in another private app without exposing it to a third party, right? Since you're the one with the encryption keys, you can run the models on that. But by being able to offer things like both TEs, trusted execution environments, and MPC, you allow for different developers to understand, okay, what level of data sensitivity am I talking about here? Like, is this a Telegram mini app, a game where you're just using you're using privacy to ensure that the developers of the game's logic aren't colluding to win the end prize, right? That's randomness at one level, but that's very low data sensitivity in terms of what would the impact or the fallout be of that data being exposed. But then if you go all the way back to what it started with, which was genomic sequencing or blood work, all of a sudden, maybe you don't want to be running it in or using some sort of privacy enhancing technology that is more susceptible to hacks or exploits. So it's all a spectrum, and part of what we're working towards as well is giving clarity not just to developers as to what they're getting out of the box, but also end users of these applications by giving a sort of scoring mechanism to each one of the apps, showing they're using privacy components for this part of their logic, but they're not for this. So you as a user should be empowered and sovereign to make decisions as to what you are willing to put at risk versus what you're not. And I think that's what it's all going to come down to, because there are trade-offs, and at the end of the day, as everyone's saying, right now, people are not valuing and they're not safeguarding their data, and anything is better than putting your blood work into grok right now, right? So I think as a starting point, any step is a good step, and it seems like we're all pretty much aligned, even if we're all taking different approaches towards accomplishing that.
Yeah. And Yannick, I just wanted, please go. And then I just want to have the take from Iris here that is have a bit.
So I think one of the big obstacles in the past really has been developer tooling as well, right? We have all of these kinds of advanced technologies, but forcing a developer to then think in arithmetic constraints, building their own arithmetic circuits, or even having to learn DSL. I think it's even a very bad user experience if a developer that wants to add privacy to an application has to learn any new development framework. I think they should be able to have privacy right at their fingertips. They shouldn't have to learn any new paradigms. They shouldn't have to learn any new kinds of technologies. They should just understand that there's this concept of encrypted data and encrypted shared state, where you can access all of the data in an encrypted way without having to expose it. And that's what we are trying to solve at Arcium, to really make that as seamless as possible, where developers can add the privacy. And at the end of the day, developers are the users for our technology at Arcium that will in turn enable privacy for every end user using blockchain, using AI, going to the hospital, going to the doctor, wearing wearables, right? So that's what matters at the end of the day, being able to onboard all of these developers, and that means abstracting all technological difficulties away.
So, if I can respond to the ZKDSL comment really quickly, I think that what you just said is abstracting the difficulty is part of why Aztec is pursuing a ZKDSL. So there are many instances where ZKVMs make sense, especially when you're trying to take advantage of all of the complex primitives that are already created in Rust, or you don't want to have to understand a new and complex language. But when there are trade-offs that make sense from the user standpoint, if you're building an app or a company, ZKDSL can make a ton of sense. So one example is there's a company called Functor. They're building a technology for AI agents. It's a key store rollup to manage agents across different chains, as they'll have different private needs around their keys. So they were using SP1. And then by switching to Noir, they had like a 100x improvement in their proving time in the browser and on mobile, which is where people will be using their app. So I think like for certain instances, ZKDSLs make a huge amount of sense from the user standpoint, especially from like proving. So what we're optimized around is client-side proving. And I think that matters in a lot of different use cases. Many of the use cases that I think will be the most viral, most useful, but obviously I'm biased, I work at Aztec, but but I think like there are other use cases where ZKVMs make sense, where other technologies make sense. And again, like to go back to this pragmatic point about AI, and maybe just more broadly about cryptography and privacy, I think like it's about all of us working together to create these different solutions. I don't know what will win. I don't think any of us do. I would just be a VC then, probably, maybe later, but
there is this combination of tech, and I think here it's kind of unfair to try to decide like what is the best use and what best privacy technology is going to be winning here, because different use cases are going to use different things. If you want to optimize for speed, if you want to optimize for data, if you want to optimize for privacy, if you want to optimize for whatever your use case is currently. We have 4 minutes. I would like to take one question from the audience, but before I want you, Iris, to tell us, how did you tackle it on your side?
Hello. First of all, I'm Josh at Iris. I know I joined this panel a little bit late. Just for some context, Iris is building a high-performance layer 1 data chain. So the goal of Iris as a chain is, can we store large amounts of data with very low latency, very high throughput? And we work with a ton of different applications that store data both in a public way, both and also in a private way. And a lot of our focus from the privacy side, when it plugs into AI, is actually more around the monetization of data, which is that when AI became very big, 2 years ago, I'm losing track of time, there were really kind of three things that became more valuable. One was compute, obviously, with NVIDIA. The second thing is talent, actually, with OpenAI hiring the best and all these AI companies hiring the best talent, kind of creating the best kind of software. And then the third category is data, where the quality of data that you use both to train and fine-tune, et cetera, is in some ways one of the largest components in how you train models and train AI. And I think one of the biggest trends that we've seen is that some of these large companies like Reddit, et cetera, have been selling data for $50 million, and times by the number of tech companies there are, how many users there are, et cetera, it's becoming hundreds of millions of dollars. And I think the main use case of privacy within the data set is actually more around how can we enforce value back to the users for the millions of dollars that this data is, and actually billions of dollars this data is being sold to users for. So I think like that's the big part of the stack. If we had more time in this panel, I kind of question the like where demand lies on the private part of the crypto stack, because I think more broadly there is kind of a tough question of like what is the adoption curve for privacy preserving technology within crypto, mostly from a compliance standpoint of like, okay, there's so much regulation, like what is the demand curve in relation to like how regulation kind of takes a decade or 2 decades to kind of really change. But anyway, I think we're running out of time, so I'll shut up.
Thank you. And actually, we're going to wrap it up. So next, it's funny that you guys put that, because next we have a panel with VCs that are actually going to answer some of these questions, I hope. So thank you so much, guys. Give it a round of applause, please. All right.